In January 2008, 9 research reactors in 7 European countries decided to create a platform for close cooperation and enhanced utilization of research reactors in Central and Eastern Europe. Thus, the EERRI, the Eastern European Research Reactor Initiative, has been established.
A few years ago, IAEA asked us, as EERRI Coalition, to help them in the developing of human capacities for future NPP programs in those countries. And we, as a reactor coalition, we decided to establish 6 weeks training course for the people who have a little or non-nuclear experience and who are affiliated or who will be affiliated in these national nuclear programs. The quality of EERRI course was acknowledged by Nuclear Engineering International Journal in 2013, where we got a special award of nuclear training.
In 2013, the EERRI course was organized in Austria and Czech Republic. The Czech part of the course took place at 2 facilities, the Nuclear Research Institute in Řeš and the Czech Technical University in Prague. The specialists from Africa and Middle East spent in Prague about 2 weeks. During this time, they took part in a mixture of theoretical lectures and practical exercises and experiments. The theoretical part covered lectures in reactor physics and kinetics, thermal hydraulics, legislation, safety, research reactor utilization, instrumentation and control, and also emergency preparedness. The issues were explained from the basics up to the examples of their practical implementations. The practical part was composed of several experiments and practical exercises at research reactor VR1.
The VR1 reactor has been designed mainly for the educational and training purposes. An open pool arrangement enables easy access to the reactor core, and trainees have a good understanding about the manipulation inside the reactor core and about the performed experiments. They can learn in a practical way how to detect neutrons, measure neutron flux distribution in the core, measure reactivity. They learn how to reach a critical state or how to calibrate control rods. By various devices, the trainees get a practical understanding of reactor kinetics and dynamics. They can practice reactor control or learn how to use reactor as a source of neutrons for irradiation or beam experiments.
One of the experiments was the NAA, Neutron Activation Analysis. The NAA shows the possibility of reactor utilization for determination of amounts of various isotopes in examined samples. This can be utilized in various fields of research, including study of cultural heritage. The examined material is irradiated in the reactor. Then it is transferred to a laboratory equipped with a high-purity germanium detector. Once the dose rate of the sample is checked, it can be moved to the defined position close to the detector, which is shielded against background radiation. Measurement and analysis of gamma-ray spectra emitted from the sample gives the information on its material composition. The work in radiation environment requires knowledge of the principles of emergency preparedness and use of protective equipment. During the practice at the reactor hall, trainees got experience with various radiation detectors and protective equipment, including suit, helmet, gloves, respirator and shoe covers. They tried out how to use them and how to avoid surface contamination. The reactor kinetics and dynamics was illustrated using several experimental devices. One of them is devoted to simulation of the bubble boiling effect in the core achieved by injection of air bubbles. Depending on the position in the core, over and under moderated condition was demonstrated by negative and positive reactivity feedback.
What do you think? This effect was a positive or negative? Negative. You know, the immediate stop of bubbles. It's a safe or unsafe? Unsafe. Why?
Nobody will be like add positive reactivity.
Exactly. Putting bubbles inside, there's a negative effect. If I stop bubbles, it means the inverse effect. There's a positive.
Finally, the students had chance to try the work of reactor operator. Under the supervision of experienced reactor staff, they could practice several basic tasks of reactor operation. They began with reactor startup procedure.
And now we can start the operation of the reactor relay. Firstly, we have to check the status of the INC.
After that, they could practice approaching the critical state, change of power level, or reactor shutdown.
Manual. Now put your right hand, your left the mouse, right hand here, and you care for the power. Increase the given power. Don't forget Deadman function. After 15 seconds, stop, increase, release, you press again. And now R1 rod, we change some 20 millimeters up to 420 to 420 20 R1
420
20.
Okay.
At common dinner, the participants and lecturers could discuss and share their past experience and issues covered during the course in an informal way. Thus, they could develop contacts for their future careers and taste a typical Czech cuisine.
Firstly, we want to thank all the staff here in Czech Technical University for they are really honest and they are cooperation with us.
During the course, I was very enjoy the program of during this training. I'm very glad because during this training I meet many people.
I found this training is very interesting and found new knowledge and new science.
Training here is very fantastic, new experiments, new knowledge for us.
What will benefit from this course? How can we deal with this reactor? How can we operate? Also, the practical is most important for us to how can we deal with the materials by our hands.
So all staff here have a good experience and have a good knowledge and a good teach how to learn it to us. So many thanks here to your honest and your cooperation.